Hey guys, so over the past couple of days we've been talking about the relationship between electricity and magnetism. One of the first things that we talked about is how if you have electricity running through a wire, that electricity actually will make a magnetic field around the wire. So imagine that I have electricity running through this wire, there's a current running through this wire, and that current will actually it'll produce a magnetic field around the wire, so that if I bring something like a compass near the wire, the needle of the compass, the metal needle of the compass, will actually be attracted to the magnetic field that surrounds this wire, and it will change direction. The needle will actually line up with this circular magnetic field going around the wire. And to illustrate more about what we're talking about here, let's take a look at the whiteboard. Let's come over here. So, right here I have a wire that's represented in red, and I have a magnetic field going around the wire represented in blue. As you can see, it's going around the wire. Now, right here I didn't complete these lines because I want you to visualize it as this magnetic field is now going behind the wire. It's like going into the whiteboard and behind the wire. Alright, so I have arrows here. Let me explain some of these arrows. So these orange arrows, these two orange arrows represent the direction of the current that's running through the wire. So the current is going through the wire, it's going from the bottom of the wire and running up to the top of the wire. Then I have these black arrows. These black arrows represent the direction of the magnetic field. They're pointing this way. All right? So when current runs through a wire, it creates a magnetic field. And it creates a magnetic field that goes in a certain specific direction. If the current is, in this case, running up the wire, it creates a counterclockwise magnetic field around the wire. Now look over here. If the current is running down the wire, take a look at my arrows. My arrows have changed. So here's the current. The current is running down the wire, as symbolized by my arrows. And now the magnetic field is spinning in this direction. All right? It's spinning in a clockwise direction. All right? So this is showing the fact that the magnetic field, the rotation of the magnetic field, depends on the direction of the current. If the current is running from the bottom of a wire to the top of a wire, then the magnetic field revolves in a counterclockwise manner. Whereas when the current runs down a wire, well, the magnetic field changes direction and it becomes clockwise. So this magnetic field is rotating in a clockwise direction. All right? So if you bring a compass needle near this, it would line up with the direction of the magnetic field. All right, let's call this north, let's call this south, and this arrow is running in this direction. So the magnetic needle, or the metal needle of the compass, would be attracted to this, and it would line up in that way. But if you brought that same magnet over here, well, the direction of the needle and the magnet would change, and it would attempt to line up, or it would definitely line up with the magnetic field that this current is producing. So if you were to take a test on this, I would ask you to determine the direction of the magnetic field. I would ask you to determine whether or not the magnetic field is counterclockwise or clockwise. And the way that you do that is through the use of the right hand rule. All right, so I have my right hand here. And what you do is you take your thumb and you line it up with the direction of the current. In this case, the current is running from bottom to top, so I give it a thumbs up to represent that the current is going up. And then I take my fingers here and I act like I'm wrapping my fingers around this wire. So imagine that my fingers are going through the whiteboard, around the wire, and I take a look at the direction that these fingers are curled. All right? These fingers are curled in a counterclockwise direction. So that's why the magnetic field around this wire is counterclockwise, because the current is running from bottom to top. Current determines direction of magnetic field. In this case, I would use the right hand rule, and if I were asked, what direction is this magnetic field spinning? Well, I would take my hand, my right hand, and I would line it up with the current. In this case, it's a thumbs down for this, because the current is running down the wire. So my thumb represents the direction of the current. And then I take a look at my hand. I take a look at the bottom of my hand here, and I realize that, hey, look at this. It's running clockwise. All right? So my answer to that question on a quiz or a test would be that when the current is running from top to bottom, the direction of the current is clockwise. Now you can memorize this, or you can just remember the right hand rule. Same thing if the current, let's say, not all wires go up and down. There's some wires that go sideways. Like let's say the wire's going to the left. So if you have a wire going to the left and you know the current is running to the left, you use your thumb to represent the current. Take a look at your fingers. If the current's going to the left, that means that the magnetic field that the wire is creating around it, or that the electricity is creating around the wire, would be counterclockwise. So the whole point to all this is that electricity produces magnetism. It produces a magnetic field. And the direction of the magnetic field is determined by the direction of the current. All right? So that's a review of the things that we've gone over so far.